Good evening, everyone. I am Trinea Reed. I am the Workforce Development Manager here at the Amputee Coalition. And this evening, I have the pleasure of introducing Solomon Romney. Solomon is the Accessibility Program Manager at Microsoft, and he's going to talk about assistive technology that you guys could use within the workplace that Microsoft offers. I also have Paula Galladay on the call as well. And Paula is our workforce development program volunteer. And she will also be available if there's any questions that come through in a Q&A or chat box. We'll make sure to get to all of your questions this evening. So Solomon, I will have you take it away.
Thanks, Trinaya. Hi, everyone. Welcome to Microsoft's Inclusive Tech Lab. Microsoft's Inclusive Tech Lab is where we develop all of our historically assistive technology, all of our hardware, specifically for people with disabilities. But our team has expanded recently, and now we also cover all of Windows. So not Office and things like that, but all of the hardware and the core operating system software that goes into our Surface devices. Well, across all of Windows, actually. So our team is responsible for quite a bit over on this side. I specifically own all of hardware. My role is all of accessibility, compliance, and inclusive design for hardware. So fun new times, new titles coming. It'll be great. We're in the midst of expanding our team this week and next week. We just doubled in size, so more people to come and play. So my role here is to, one, make sure we meet our government compliance requirements, which are based on the ADA and things like that, but are specifically the standards to which we have to report our procurement rules. So, and I know that I'm probably getting into some weeds here in the beginning, but I want to sort of lay this out a little bit because we're going to talk about it in a couple of ways here. So in order to be legally compliant, meaning we can sell to governments, we have some very set but also dated standards that we have to adhere to. So for example, does a computer use Bluetooth or USB? That's required. Does it have bumps on the F and J key? That's a requirement. It's real basic stuff. And so just because a device is compliant doesn't mean it's actually usable. And that's where the other half of our work comes in, where we do inclusive design, which is to make sure that we are purposefully and intentionally designing with the disability community to ensure that our products actually address needs in usable ways to actually help you game better or work better or things like that, rather than just providing the legally required bare minimum of access. So that's why I'll try and get back out of all that technical jargon, but you'll hear me talk about compliance versus usability a bit as we move through this. So I just wanted to sort of define some terms. We will move through the lab a bit while we're here. We do have a physical space that we do this work in that is designed specifically as a place for the disability community at Microsoft. And we mean that in both ways, both our internal disability community and also the broad disability community to come and have a space dedicated at Microsoft. So our work is every day, our work involves direct interaction with the disability community. And that is always and will always be the charter of the work we do, is that it must be in service to the community. Now, I'm limb different myself. My boss has cerebral palsy. Hardware predominantly focuses on mobility, which I'm sure is going to be especially pertinent to this conversation. But we also work across all the disability categories. So we do work on vision, we do work on hearing, we do work on mental health and neurodiversity. And where possible, we will layer solutions to serve multiple needs. So we'll get into some of the specifics here in a bit. I definitely want to start with gaming, which is where we started, and it's where our You know, it's where veterans really played a huge part in starting the work that we at the Inclusive Tech Lab get to do. Like, the lab doesn't exist without the Xbox adaptive controller that we'll get into, which doesn't exist without veterans. So that all being said, this is an open question forum. I've got way more stuff here than I can show you in a single hour. So if you see something or I say something and you want to know more about it, you want to dig in deeper, put it in the chat. I don't know exactly the rules if you can come off mute and speak, but certainly type it up and I will address them in real time, you know, as quickly as I can. I'll be monitoring the chat. Trinai and Paula here to help with that as well. You know, don't hesitate. You know, I've given tours of this space. I've done this speech, I don't know, 500 times now without much exaggeration. So you're not going to throw me. There's not like a set script or anything. So, you know, I really want to pursue your curiosity as things come up. I want to hear about it. So let's head over here to Xbox and we can talk about where it all began. So the lab originally was an Xbox lab. We started as a gaming focused space, and gaming's still a huge part for us. But I want to start talking first with this, which is our standard controller. So we've spent, you know, 20 plus years across multiple generations of devices and millions of dollars to make millions, tens of millions of these, and to refine it and rework it so that we reach the point where we believe we have the greatest gaming controller in the world, which you are welcome to disagree with that. Just don't tell me. But what is, but the issue we run into with this is that it's based on certain assumptions. So it assumes that you have the strength to lift it. Oh, I see the problem. I'm like, why is my video weird? Because it's using the wrong camera. Sorry, folks. That's why it looks a little odd. Let me fix that really quickly. That explains it. I was like, why is everything up here in my chin? There we go. That's more like it. Cool. Now you can see things. Yeah, so yeah, this is based on the assumption that you have the strength to lift it, the endurance to hold it up for an extended period of time, and the dexterity to hit all of the controls, which if you don't, then the controller is the disability. And so working with a nonprofit called Warfighters Engaged all the way back in 2015, we set out to make gaming more accessible for wounded veterans. I probably don't have to explain to you all, but I will say it here for the record that we know gaming is a huge part of the military culture, and not being able to game can be very isolating, can be very detrimental to mental health, to well-being, to social interaction. And so we saw a very significant need in this space. And people had been making adjustments to controllers, custom work for years before this, where they'd crack the controllers open, they'd solder them together into these really custom specific rigs around people using switches, which if you're not familiar with it, a switch is a simple, we're going to talk about these a lot. It is a simple button off on, just like a key under a keyboard. And these have been around for decades, at least back into the early 90s. The mobility community has used them for things like for wheelchair access and stuff like that. In fact, they're probably older than that. Stephen Hawking used a switch to navigate through his communication software. They use audio jacks, mini audio jacks to connect because it's low power. It only requires the on-off signal. and things like that. And so we'd see people make these custom setups using switches that they'd arrange around the person wherever they had movement. But the problem with that was they were expensive, they were delicate, they required a lot of special expertise and knowledge, and were just not something that was easy for people to get to. If the system changed or they broke a component, getting repair work done, getting anything improved or added on was quite challenging. They were also generally quite expensive to produce. And so it was a situation we looked at and we said, we can do that better. So what I'm going to show you here, I'm going to show this video, and I know it's weird to watch a video on a video, but what I want you to be able to see here is this is Corporal Todd. He is a quad amputee, and he is using a system that predates the adaptive controller. But just to give you some idea of sort of what setup Corporal Todd had. So what you'll see here is he's got these lever switches down with his legs. He's got a chin switch up here. He's got a series of buttons, and he's got a couple of different joysticks over here. And right now, with the way that it's set up for Todd, is these are all wired together and soldered together through a broken controller, essentially, a cracked controller that allows them to sort of stitch this all together. It's very complex. These are very expensive components. Todd's quite good at this game, actually. This is Killer Instinct. He's very effective. But it required very special hardware to do it. And so we looked at that and we said, we can take the engineering part of that and do it ourselves, do it faster, do it better, make it easier to use, make it more plug and play. And so just in the interest of time, I will skip the various prototype and hackathon stages we went through, but this did go through, it was a good solid 3 years of development before it was released. And I said hackathon, I know that's not a familiar term for everyone, so let me define that really quickly here. A hackathon at a tech company, they're all handled a little differently, but essentially what it is you usually get a small amount of time. For us, that's usually a week, where you get to work on whatever you want with whomever you want. And so, for us, it could be, we'll have people from marketing or business, and they want to work on I don't know why I'm making this complicated. They want to work on gaming hardware to make it more accessible. They may not necessarily be engineers or designers, or they may be, but they don't ever work in that space. And Hackathon gives us the opportunity to follow our passion and to work on the things that we find personally important. And at Microsoft, we find every year there are over 90 hack projects specifically focused on disability experience and hardware specifically designed around disability needs. So this went through that process twice and was worked on continuously throughout those years as well. So after 3 years, we ended up with this design, which is its own controller. Originally, it was designed as an add-on to existing controllers, but we found that actually was more expensive than building its own controller, and it limited our ability to do the work we needed to. Because essentially what we did here was we took every button on a standard controller and we put them into these ports. So these are those 3.5 millimeter audio jack ports like we used to have on phones, or you'll find them on laptops and stuff still, so that we could just plug switches in. And every one of these corresponds to an existing button on a standard controller. So I can just take this switch that I had here a minute ago, and I can plug this in here, and now this is my X button. And I can put it wherever makes the most sense for me, without having to go and do a bunch of soldering or programming or things like that. I can just put it where it makes sense for me. And that was the simplicity of it, was just the plug and play. And that was the idea. If you're not familiar with switches, they tend to be quite expensive. And you can get them as low as $40, but most of them tend to start in the 60 to 80 range and go up from there. We partnered with Logitech. About a year after this came out, they released their adaptive gaming kit, which is 12 switches for $100, which is was a huge game changer. And actually, now that PlayStation has released their version of an adaptive controller, Logitech has now updated their kit for PlayStation as well. Same switches, they work across, whatever, and they'll work on anything, honestly, that uses a switch interface. Just different colors, blue instead of green. But that was a huge step in helping to make this a more affordable solution. Because for a lot of folks, they would need a number of switches that actually would end up being more expensive than the controller and the console combined. And that's just not, that isn't friendly to users in the way that we want it to be. Like, yeah, we'd provided access, but now we needed to make it usable by bringing cost down. And that's why we partnered with Logitech to do that. So this was developed, we didn't, like observe veterans or have a couple conversations with veterans and then go off and do all this work on our own. Veterans and other folks with disabilities like myself, I was involved in this. So before I came to join this team, we were there the entire way. From the original ideation in that tent during hackathon all the way up through post-launch. Like, that is a driving principle of the work we do here, which is, you'll hear some different phrases, nothing about us without us. We design with, not for, the disability community. And so it's been vital to us. It was vital through that and all the products that have come since to have the community there with us through the entire design, development, release, and support process. And we carried that forward in other things that we'll talk about here in a minute. But I want to take a quick pause and see if there are any questions or thoughts or something you want to learn more about here that I haven't touched on with gaming yet. All right. I give the pause just long enough to be uncomfortable, because I hate it whenever someone says, do you have any questions? And then immediately goes on. So with that, we will transition over to, I want to show you what we call the spiritual successor of the adaptive controller, or the version that we made for productivity. So I'm not doing these in chronological order, but I think this is our next natural progression. So we're going to head back over to the table here. And then I will have something else I want to show you in a minute. But over here we have, what's the loose? I'm hiding things on me here. These are our Microsoft adaptive accessories. And so it's essentially three main components. We have a mouse, which is this series over here. We have the hub, which is essentially the child of the adaptive controller. And then we have our buttons, which are, there are a bunch of switches inside. So like what we just looked at wired, there are a bunch of those inside each of these buttons, and these are wireless buttons. So we've made some advancements, but I'll take them each piece sort of in its turn. The mouse starts as this little core. So this is our Microsoft Adaptive Mouse Core. It is the lightest wireless mouse you can buy. It requires very little force to move it, very little force to push the buttons and anything like that. Designed specifically for people with muscular dystrophy and other disabilities that prevent gross motor movement or strength. So this requires very light force to interact with, but we've created it in such a way that you can tune it to still give you full control over the screen. So even with just the barest of movements, I can still get the same kind of mousing experience you would get with a traditional mouse. And this is great. If that's all you need, fits really well in a pocket, it travels well, cool. But if you're like me, like my typical limb is quite a large hand, And my limb different limb is quite blunt, and this is a bit too small for me to use over here. It doesn't match with my needs. But we thought about that, and what we did is on the bottom here, there's this big eject button. And when I push that, this back plate comes off, and it opens up this little attachment point inside. And what that allows me to do is take things like, we made this standard mouse tail. We made a bunch of others too, but I can take this and I simply slot it in. And now it is a much more traditional looking mouse, which if that's what you need, great. If it's not, we've taken it a step further. By using 3D printing, we've been able to create a whole bunch of different tails for the mice that are custom and can be customized. So this is a child-sized tail, so it's made for a smaller hand. It's heavy, it's solid, it's got these thick plates over the buttons, it's got these deep scoops to help maintain finger positioning. It's got this flexible, high friction thumb rest on the bottom. And so what we've done is take that ultralight mouse and make every part of the interaction with it harder. And by doing that, we've actually made it more accurate for the individual who this is designed for. This is specifically for a young girl with cerebral palsy. So this is I don't necessarily want to call it a tremor filtering mouse because it's not what it does, but we've used a pure hardware experience to help her have better control over mousing by requiring intention. So she has to really be forceful about clicking. She has to really be intentional about movement and things like that. So when she has uncontrolled movement, it doesn't accidentally move or activate the mouse. And so there's a lot of different things like that. We've seen some very interesting modifications to the mouse, some interesting tails. There's a hospital in Japan that's made this quite interesting vertical, almost snail shell type of tail that allows your hand to sort of stay in this position and still get full movement and button control. And so there's a lot with the 3D printing that we can do to open that up. We also recognize not everyone has those skills or those tools available. So we've partnered with a company called Shapeways, where you can go and configure these things and have them printed and shipped to you. You can order them from there. There are also a lot of other great organizations like Makers Making Change in Canada and folks like that who also have been designing and release designs and can print things as well. So we partner with universities and a number of other folks to help provide those printing services. We make all of our designs, all the 3D designs are free. You can download them for free. We give them away. You do have to download them from the Shapeways website, and they do hide them a little bit, but you can get them there because we don't want to be introducing any new barriers into getting you what you need to be effective at work or at play. So the next piece, just really quickly, is this little hub, which is this little box. You'll notice there it's got those same ports. This is the brains of the operation. It's what holds all the memory for the buttons and what interacts with your computer. So the buttons don't work without the hub. You need this to manage all of the instructions. And then the buttons themselves come in a couple of different styles, but they all underneath are the same. And essentially what it is, it's just these little boxes. They're the same size basically as the mouse. And there are 8 switches in a ring under the top of this cap. And you can program every one of those switches to do any mouse or keyboard function you want. So if you need this to be right or left click or mute, unmute, camera on, camera off, that kind of stuff, very simple things. Copy paste we find is hugely popular with these. Anything that requires multiple keys or that you do repeatedly that can be simplified down to fewer clicks. We have a phrase, that we believe in here, which is, the fewer clicks, the better. Every keystroke is precious, as Dave says, my boss. And that's because he and I both struggle with these types of things. You know, my hand wears out. Dave has a difficult time using any keyboard. And so anything we can do to help automate that process means we can work faster, we can work longer. We can actually, you know, in some ways, there are things that we can now do that we couldn't at all with the introduction of things like this. So like Dave has set his up in a way that allows him to dictate messages and using voice access on Windows and things like that. So that he really only has to push the button once and he can get it to bring up a new email, and he can search for names and do all that. He's got a real complex setup with it, but with a single press, rather than having to do all these mouse movements and keyboard, you know, all the typing and stuff, he can do it very quickly and easily with a simple button. And so that's really the power here. But what's cool about these as well is tops come off. And so we can change them out with other 3D prints, like this particular one, which is designed as a chin cup, or this, as we call it, the sunflower, which gives you larger targets to hit. You also don't have to use all 8 if you just want 4 or 2. You know, there are things like split cap and things like that that also can be used to reduce the number of targets you have to hit. I don't want to get, I'm trying not to get too like jargony about stuff, but one of the things that we are really focused on right now is what we call precise outcome from imprecise input. And so the idea there is that mousing is very precise, typing is very precise. You have to hit something exactly in a certain way to get a very specific outcome. And so what these tools and what our new approach is how can technology take a really imprecise input? Like, for example, a touchpad requires very precise fingertip movement. Well, how can I get the same experience on a touchpad using a limb like this that doesn't have that precise movement? How can I have this input and this input provide the same specific output? How can I get the mouse to react the same way? And that's where the technology comes in. That's that lens. And that's what we really are focused on right now is how do we make the system more forgiving? What if I don't hit it quite right? What if I get close? Do I have to start all over again and try to hit that small target again? Or can we make the system smart enough to recognize intent? I was trying to hit that based on context clues, and so it's going to provide that, even though it's not as precise as it traditionally would require. So I know this one we tend to get in the weeds a little bit on this one, just because there's so many layers to it. But I'm going to take another pause here. If anyone has any questions about these productivity tools, I have more stuff I'm going to show you, but pause here with the adaptive accessories. I know it's a lot to take in. So.
We didn't have any questions, Solomon, but
Okay.
Carl did mention that it was very interesting when you showed the different adapters for the mouse. He said that was really interesting.
Great. Yeah, thanks, Carl. I appreciate that. The beauty of the 3D printing, just to sort of snowball on that a little bit, is we can keep making designs. You know, usually in hardware, we make a thing, we design a thing, we make a thing, and we release it. And that's the end of it. We're off to the next thing. Where with the 3D printing, we now can design a thing, make that thing, release that thing, and continue to do more designs as we get more feedback from the community, more involvement. Oh, the Q&A, that's what I should be looking at. Yeah, and so that's a huge advantage we're coming to find with a lot of these things, because we can't make the perfect solution for every person, for every need. Weirdly enough, we're too big for that to be done effectively. And so 3D printing allows us to make all of those additional pieces, all those special customized pieces that people need without us running into the limitations of manufacturing. And that's proven to be really beneficial for us and to users to really be able to hone in on their particular needs. So do we work with artificial intelligence? Yeah. Yes and no, Carl. In terms of, is it involved in our design process? No. All of the design work is done by humans. All of our research is done by humans. Where we use AI in our work, Dave uses it for automation. I'm looking at using it for automation and things like that, similar to what we talked about with the button. And of course, we just released a new wave of Copilot Plus PCs, which have a lot of AI on board and a huge amount of potential for accessibility purposes. And we are exploring all of that. And that's really where we get into AI, is looking specifically at how it can be used to augment experiences, or how it can be used to bridge some of those gaps. That forgiveness thing I was talking about is a place where we think AI has great opportunity, because it can take in the context in terms of determining intent. It can analyze patterns. It can see where you struggle to hit maybe the same key every time, or you make the same correction every time, or things like that. And then it can adjust in the background around you. And so the philosophy around that, and we think, again, that AI is a big tool about this, is not we design a thing and you have to figure out how to adapt to it. It's we design a thing that adapts to you. So we put the person with the disability at the center, and the system evolves and shapes and morphs around you. And AI is going to be a huge enabler of that. We also recognize that there are potential privacy concerns around how much information anyone gives to AI, but specifically for folks with disabilities, how smart do we want the environment to be around us? So the same way we talk about email and typing and things like that also applies to space. Like if I have an AI assistant that notices, depending on how much information you want to give it, it notices that a certain time of day I have a certain physiological reaction because of temperature change or a lighting change or what have you, and it adjusts around you. But that level of sophistication requires giving that system very sensitive information, your personal real-time medical information, which is something we've heard from members of the disability community that have very severe mobility disabilities. They want a much more responsive environment. And so our role is also in some ways to safeguard that security, to ensure that we are using AI for good, and that it is being used in ways that are beneficial to people with disabilities and not exploitative or subversive. And so, yeah, we're in a new frontier with AI, and there's a lot of work we've been doing with that, which is not traditionally our space. And that's why our team has grown recently, so that we have a dedicated side just for Windows and AI and all of that. So great question. It's one that we do get a lot. It's something that we're actively thinking about every day. We talk about it. So cool. So let's talk about some simpler things, because I think you may find that a lot of the frustrations, at least that we hear from folks with disabilities on a daily basis, are actually the small things. It's not, oh, I'm trying to build this PowerPoint about this trip I want to take or whatever. It's can I open the lid of my laptop? Can I get the cord plugged in right? Can I find the right key that I need? It's that real simple stuff that become the biggest barriers. And so we set out, between the adaptive controller and the adaptive accessories, we set out to solve some of those simple but high impact problems with simple solutions. And so we made a box of stickers. which is a little bit of a flippant way of saying it, but that is ultimately what we did. We created the Surface Adaptive Kit. Oh, I think this one's empty. Yep, this is the display one. And what this was designed to do was make it easier to just interact with the computer physically. And so it's made up of 4 different pieces. And the first one are these bump labels. And so these are little, dots. They have a little bit of a grippy texture. They're brightly colored. They're in different shapes. The idea being that they're easier to find by vision and by touch on your keyboard. So if there's a particular key that you use all the time, Alt F4, for example, is close program. F7 is spell check. And if that's something you're using all the time, you don't want to have to visually search for it. So putting a dot on there makes it easier to find by touch. So this is good for mobility and for people with limited vision. And then the next one is going to be really hard to see because it's not designed to be seen. It's these clear caps, which provide a set of symbols and things as well. Very specifically not Braille, but clear caps that give you the same sort of tactile benefit. So you can put these on keys as well. And these were designed specifically for folks who are blind or who want the benefit of a tactile assistance for wayfinding, but don't want all the color, don't want to draw attention to. And then the next piece, let's see, Carl, I see your question, and we'll come to that in just a second. The next piece are these what we call port labels. And so these are also brightly colored. They do have textures to them, which I'm trying to show you here. There are different patterns printed on each one. So like the blue has circles, the red has dashed lines, the sort of gray one at the bottom has a zigzag line. And these are designed so that you wrap the long one around a cable and you put the short one on the port that cable goes to, so that you visually and by touch know exactly where that cable is supposed to go in and what orientation. Because I'll tell you, for me, every time I try to plug in a USB-A cord, it's always wrong. It's always the wrong direction. Or it feels like it's the wrong direction. And then I go through that dance, like so many people do every day, flipping that thing around, which if you don't have great mobility in your hands, or you don't have hands, or you can't see the port, that becomes a real challenge. And so that's where these come into play. The next component, the last component, my personal favorite, are these openers. And they exist in sort of 2 forms. So the first one, which is my personal favorite, is the lanyard pull. So I used to walk around and carry a Surface on my arm like this all the time because I didn't have a desk. So I'd be sitting and typing like this. And I dropped one every 6 months for years. And they hated that. And so what I ended up doing was drilling a hole in the kickstand and putting a lanyard through it. And I'll tell you what they hate even more than you breaking them every 6 months is putting holes in them. And so we decided that we would build a sticker that would allow me to do that without drilling holes. And so now I've got a safety band. I can easily open the kickstand, makes it much easier to interact with. And then the other one is this D-ring. And this is flexible, it's rubber, bends really easily, makes it possible to open the keyboard much more easily than or the lid, I should say, than it would traditionally. So like I'm able to get my thumb in here, my partial thumb, and open that really easily. And as you'll notice, the adhesives are quite strong, holds up really well. We've worked a long time on that glue, I'll tell you, which for folks who are used to working on things like metal was a whole adventure. but it's simple things designed to solve simple problems. Simple problems require simple solutions. So that's why we made a box of stickers. So Carl, you're asking about adaptive equipment for smartphones. Yeah, and a lot of folks back in the day, like 10-ish years ago, maybe not quite that long, when our CEO was fairly new, he came up with a new phrase about how we should think about computing, which was mobile first and cloud first. Vast majority of folks spend their time on these, not on these. And so he wanted us to think about it from that lens. And so those adaptive accessories that I showed you, we designed specifically to work on mobile devices. So for example, let's say there's a phone number that you call all the time, but for some reason you have to dial it. Let me think of a better example. Like let's say you have, you've got to call into the VA to get help with something, and you have your member number that you have to provide. But typing that out every time, potentially multiple times per call, can be really challenging. You can program the button. Now, don't quote me on this. We haven't tested this, so I have to go in and check on it. But in theory, you should be able to program the button to input that sequence of numbers with a single press. So you hit that call button, it goes to the menu, and you hit that button on your adaptive switch, and it just puts that number in. It essentially treats it like it pressed all those buttons. So you hear the little audio cue. It's not saving any of that information necessarily or anything on, like it's on the device, but it's not, you know, it's not like that's something that could be easily broadcast or stolen. It's telling the phone to press these buttons, basically. Like that would be one way in you know, you could potentially use these products. That we find people love the lanyard for mobile devices as well. I actually, for a long time, would put the bump labels on the edge of my phone case because I tend to have really slippery cases, and having that extra little grip at the corners made it easier for me to hold onto my phone and use it one-handed. I got a new case that's not quite as slippery, so I haven't put it on here yet, but I probably will, just because that extra grip is really handy. We find people are putting those stickers on things that are not computers all the time. Appliances are a big one. Our blind friends who get the kit, they tend to buy a bunch of them, and they just put them on all their appliances. Because when was the last time you saw a microwave that had physical buttons? That wasn't just a flat panel? Decades, right? I think I saw them back in the 80s, maybe the 90s. But now we've got dishwashers and refrigerators and washing machines that have all gone to that flat panel technology, which makes it really hard to find things by touch. The new heads-up displays in cars that are all touchscreens, we're running into the same kind of problem. Like that was sort of the beauty of having physical dials and things in a car, is you could feel your way across without having to take your eyes off them. And so, yeah, so we do see mobile stuff in that sense. We also have apps that we develop predominantly for vision, less so for mobility, just because vision tends to be where software focuses, because computing is such a visual medium, where we tend to focus on physically interacting with the object, and we don't make phones. So it's a little bit of a different beast for us. But yeah, we have things like Be My Eyes, Seeing AI, which are available on our phones. They're free, are available on phones and are free, which are designed specifically to assist blind users with navigating the world. You know, so we do that kind of work as well. That's not driven by our team. I want to be really clear. That's handled by software teams and other parts of Microsoft, but we support that work and we showcase it here in the lab. So, all right, we've got about 10 minutes left.
Well, I have a couple
Yeah, Paula.
questions.
I think one of the biggest thing relating to workforce and people getting into either into the workforce or now have become an employee, and they're going to their company and saying, "Hey, I can't," whatever the plant is. I know as a former federal employee, there are many things you cannot bring into
Right,
the workforce and plug it in. You
right.
want to wear a headset, they don't care unless you're plugging it into their computer. So if that can be addressed, as well as even in the private sector, what they're more likely to accept as an accommodation. I know I worked in the field for a very long time. The average accommodation is less than $500 over the course of the whole span of the person being
Right.
employed. However, you'll see hackles going up as long as you say it's going to cost more than 53
Yeah.
cents, if that. So if you can define some of that, where and I know Microsoft supplies pretty much, well, it's the only software overall that the
Yeah.
federal.
Yeah, those are great questions, Paula. Part of the reason that we are so keen to build so many of these features into Windows is so that you don't have to go and get a firewall exception or get an IT policy exception every time you need a particular piece of assistive technology, because we know that is one of the biggest barriers to getting things like JAWS or NVDA, the screen readers, for example, or dictation software like Dragon Naturally Speaking, or things like that. And so that's where we've spent a lot of effort over the last decade, and especially over the last 3 years, getting things like voice access just built natively into Windows, because then there's no approval process that you need to go through. It's just built in. So doing our best to just make the entire system, the base vanilla system, if you will, more accessible, and have that information, have those tools just readily available. So you don't even have to go necessarily request an accommodation. You just have the tools there to explore or use, and then it's really more, and then the question becomes about getting training on how to use it, and less about getting approval to use it. And it being built in, there's no added cost. So from a software perspective, that's a big part of how we're leaning into those sorts of things, of getting, of just getting it built in. Fewer separate apps you have to download, fewer approvals to go through, no cost. As we make our products more accessible, all of our customers become more accessible by default.
And then
So that's the philosophy we take to software. Yeah, sorry, go ahead.
What do you see with the hardware, such as the adaptable mouse?
Yeah. So hardware is an interesting beast, because it's so two approaches. We have two approaches. Similar to software, we're doing a lot of work to just build more accessible devices across the board. And so things like our haptic touchpad, which is in our Surface Laptop Studio 2, the new Surface laptop that was just announced a couple weeks ago, and our new Surface Pro keyboard for our tablet devices that was announced, all have what's called adaptive touch mode, which is so the example I was giving earlier about the mouse and this finger versus this hand, that's an actual solution we've worked on. And so we've made it so we have what's called adaptive touch mode built in, where I can use a touchpad with my hand that traditionally has not worked. So we went in and we created a whole separate mode for that. So you can mouse effectively without a finger. You can use the feet, you can use a partial limb, residual limb, to effectively navigate. So that's just built in. And that philosophy does exist in hardware as well, where we're just trying to make everything a little more accessible on what we call our existing platforms. So that if you buy one of our laptops with Windows on it, and this is not a sales call, I want to be real clear, I'm not trying to sell anybody anything, but the philosophy and what we're driving for is you buy one of our laptops running Windows, The hardware is going to be the most accessible you can get, and the operating system is going to be the most accessible you can get just by design. So less and less requirements for extra pieces. Now, for things like the adaptive mouse and things like that, we recently went through a new, back in March, we announced that they are available for our corporate customers, which is something we'd never done before. They've only been available for consumers, which is great if you want to go buy your own tech, but we recognize that the vast majority of people, and I think Paula, you and I have talked about this previously, the vast majority of people get their assistive technology through their employer, through schools, through hospital systems, which at Microsoft we would call all of those commercial or enterprise customers. And up until March, they weren't able to buy these things in the volumes that made sense for them. Like if a school wanted to outfit a class of students, they had to go buy them in small numbers with a credit card, which isn't how they do things. And now they can go buy them in bulk using purchase orders, which is the preferred method, and then distribute them. And so for us, one of the biggest problems we found was just making them available to businesses and to governments and things like that in a way that made sense with their procurement rules or processes. So that's a big hurdle we finally overcame back in March. And going forward, every piece of assistive tech that we build, and we've even gone in the back catalog and fixed this for existing ones, is available for commercial customers, which means it's easier for you, the end user, to get it through your school or your hospital or your employer. Because with the adaptive accessories specifically, what we've wanted to provide, and with the new Surface Pro Flex keyboard and stuff, which is large print, by the way. I know it doesn't make a lot of difference when I show it by itself, but this is a much larger print if you look at it versus the one on your keyboard. They don't have added cost, and they're just available for everyone. We're not going to have them separated anymore. There's not going to be any of that nonsense. But what's also great is they're just on the shelf available, just off the shelf. You can get them, use an IT pro or whoever. Like, this doesn't require any special setup. You just plug it in. Same with the mouse. It acts the same as any other mouse. The switches do require a little more effort, but the idea being that it's just as low friction as possible for you to just get someone set up. So we're approaching this from as many different angles as we can. And then in the next couple of years, in the next 2-3 years, we're really going to be 5 years, if you really want to get wild. We're going to have even more of that just by default. The computers are just going to be more accessible. Our goal is to become the most accessible computer brand in the world. And we're well on our way to doing it at no added cost. Yeah, like we're not going to charge you a tax.
Follow up, I apologize.
Yeah.
On the stickers, all right?
Mhm.
Can they be produced economically in Braille for individuals who do not, because a dot in Braille can
Has
mean
a
period.
Yeah.
Depending on where it is, it can be a period, it can be a comma, where if you just put a dot there, well, what am I hitting?
Right. Yeah, we very specifically, because we put what we call port indicators, which are a series of tactile bumps on a number of our devices to designate differences between ports. A USB-A port and an HDMI port can feel very similar, can also feel similar to an Ethernet port or a power jack, depending on the type of device power cable you're using. So for all of those different tactile indicators, we very, very specifically have made sure that they don't feel anything like Braille. We put Braille on our packaging to help with setup and things like that. But in terms of making a set of stickers like that are Braille focused, that is something that we would partner with someone like the American Clearinghouse for the Blind,
Right.
ACB, to help them develop a tool like that, or for them to inform us in the development of something like that. We'd partner to make something like that work. because we find here, and we find this in a lot of other places too, there's a strong desire to put Braille on everything. And we go, sometimes that doesn't make sense.
Right, there's
You've
also
got to use it in the
laws.
right way, in the right place, at the right size and things like that. And so a lot of, the nuance around that is what we try to weave throughout the product making is, where is Braille appropriate?
Mhm.
Which is, where are we presenting letters and words versus where do we just need to make it so someone can tell the difference between a couple of ports, or what have you. And so it is something that we wouldn't be the ones to do it, because I will tell you, building this was a surprisingly difficult process, because it's not something we'd ever done before. It required new tools and systems and approval processes and new standards, all sorts of stuff. We had to essentially start from scratch to do it. And that added cost that we hadn't anticipated or wanted. But being able to take all of the expertise that we have and help someone like the ACB create a version that really makes sense for them and for their audience, absolutely. We are not shy about sharing things here. We are probably the most open team at Microsoft when it comes to sharing what we know and sharing what we do and what we make. There's no value to us or our goals in hoarding or keeping things secret. So we make a point wherever possible to be as public, transparent, open source, if you want to use those words, as we possibly can. So, yeah. You're welcome. I don't see any more open questions, and I know this hour has just flown by for me. I hope this has been informative and useful to you. And I will say, if you do have questions, or you want to learn more about something, reach out to Paula, reach out to Trinaya, and they can reach out to me if there are things that I can answer. I'm more than happy to do that. So, don't be shy. If there's anything we can do to help, let us know. That's why we're here. So, with that, thanks everybody.
Well, thank you, Solomon, for such a great presentation and for you giving us a tour of the innovative lab and assistive technology that, our workforce development participants and our attendees on the call can utilize, whether through the workforce or through gaming. Super, super informative. So thank you so much for your time.
My pleasure. Yeah. Look forward to talking again soon.
Likewise.
Have a great evening.
You too. Bye-bye.
Can't wait to see you at conference.
I know, so soon. It's coming.
Yep. Bye-bye.
Bye.